There we go. So as we discussed 2 weeks ago, what was the general form of a confidence interval? Anyone remember? So you had some point estimate. And then we added and subtracted, what was it called? Yeah, the margin of error. In this case, we're going to talk about a confidence interval for the population proportion P. So it says the last type of confidence intervals we discuss is blah, 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 just what I said. Let's say that the survey states that 68% of all OSU students own a car. From this, we can tell the population of interest is what? Yeah, we're talking about all OSU students, so the population of interest is all OSU students. And then what does it say after that? And the population proportion is what? Yeah, 68%. Is everyone okay if I shorthand pop prop? That just means population proportion. What's another way you could say that? Turn percentage into something else. Yeah, 68 out of 100. That's assuming we have a sample size of 100. When we recognize fractions, decimals, or percentages in our word problems, we use different formulas that are specific to proportions. And it says, note, proportions can also be probabilities, so expressed as a decimal. For example, the probability that a randomly selected OSU student will own a car is estimated to be what we said, 68% or 0.68. When dealing with proportions, our notation changes. So in this case, I'll just write it up here. The population proportion we'll denote as P. And then the sample proportion is P hat. The hat on top means the estimate. And we're going to define this by X over N, where X, all right, gosh dang it. Where X is defined to be the number of, how do I write it? Sample units that possess the characteristic of interest. Is that how you spell possess? No idea. Good enough. Characteristic of interest. So in this case, what is the characteristic of interest in that example we just talked about? Close. That was the population. What are we interested in? What do they have a car? So in that case, X would represent the number of people who have a car out of the total sample size N. And N is the sample size. Then as it says here, if I take a random sample of 150 students and find that 89 of them said they own a car, then the sample proportion would be, so in that case, X is the number of people who own a car. X is the number of students who own a car. And we say, in the problem, that is equal to whatever it says, 89. Is that right? Yup, 89. And then what was the sample size? 150. It said we asked 150 students, so then N is 150. Then you can calculate p hat from that by just using x over n, and you get 89 divided by 150. And if you want that as a decimal, it's 0.59. Then we can also define the sample proportion of students who don't own a car by what? If you own a car, then obviously it's the opposite of not owning a car. So then how can you find what we call Q hat? Just 1 minus P hat. And that would be equal to 1 minus 89 over 150. If you want to be in fractions, that is 61 over 150, or in decimal form at 0.41. And what do you notice about when I add these two together? What do you get? 1, as you should, because when you add two probabilities together that are complements, you're going to get a probability of 1. So you'll need to know this idea for, I don't know what number it is on your homework, but I know there's 1 on there. And since in this case, we can't gather all the information from the population, we use this p hat to estimate p, just like we did in the previous section when we used x bar to estimate mu. And, oh my Lord, this formula. And the confidence interval formula is given as, so you have the point estimate, which is p hat, and plus or minus the margin of error. And in this case, we're going to use a critical z value, just like we did in 7.1. And then the margin or the standard error slightly changes, p hat times 1 minus p hat over n. And if you want to do what we did last section, this is the point estimate. This is the critical value. This is the standard error. And then when I multiply these two, what do you get? Yeah, margin. So the idea here is still the same, just the formula will change depending on the situation. Blah, 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 blah. You don't really need to know this next part. It says, notice how we're back to using z-scores again. This is because the sampling distribution of the sample proportions is approximately normal with a mean of p and a standard deviation of p times 1 minus p over n. Do you need to know that? Not really. You may need to know these conditions below, though. They may pop up on a true or false question or multiple choice. So when finding confidence intervals for the population proportions, our assumptions slightly change. So we still have the sample as random. We have that the mean, if we have of a sampling distribution, n times p hat is greater than 5. And then n times 1 minus p hat is greater than 5. And the last one, the conditions for a binomial experiment are satisfied. Anyone remember those conditions? Okay, the first one, 2 outcomes. In most cases, they call them success and failure. Second one, trials are independent of one another. So that means what happens on one trial will not affect what happens on the next. There are a set number of trials. That just means there's a fixed number of them, set number of trials. And the last one, anyone remember what it is? So if the trials are independent of one another, what happens to the probability of success for each trial? It remains the same. So the probability of success, P, remains constant. Then let's look at an example. you want me to go through the step-by-step thing or just do it all in one? I don't care. Okay, step-by-step, cool. That's the one bad thing about having the camera just point at this board. I have to erase it all the time. It says a survey of 1,400 randomly selected students found that 325 of them paid for their education with student loans. Find the 90% confidence interval of the true proportion of students who paid for their education with student loans. And how do you interpret this interval? So let's first identify what p hat is. So in this case, it's the sample proportion of people who paid for their education with student loans. That was me. OU cost way too much. Not a fan. I don't know how much this costs, but I'm assuming it's around there. So in that case, how many people have been paid with it for student loans out of the grand total? Yeah, 325 paid for it with paid for their education with student loans out of the sample size of 1,400. That implies the sample proportion of students who pay for their college with student loans is, whatever that is a decimal 0.23. So this is the first part, the point estimate. The second part, anyone remember what it was? Find the critical value. So you'll need to know how to find these. It's going to come up in the next chapter when we talk about critical values for hypothesis tests. In this case, we're dealing with the Z distribution. And for a confidence interval, you have a lower cutoff and an upper cutoff, and the area in the middle of those two Z scores is what? The confidence level as a percentage of 0.9. And what does that imply about the area in these two tails remaining? So the total area under the curve has to add up to 1. So therefore, in these two tails add together, have an area of 1 minus 0.9 or 0.1. So I'll do it this way. This plus this, 0.10. So that implies that what area is in each tail? Yeah, 0.05, 0.10 over 2. That implies that this is 0.0. What the? Implies that this area in this tail right here is 0.05. Then what you do is find the corresponding Z alpha over 2 value for that area to the left. And if you do that, set up this, the probability of Z being less than or equal to negative Z alpha over 2 is 0.05. And someone tell me what that is. This is one that I said it could be two different values. But your homework will take the upper one. So look for 0.0505 on the table in the middle and tell me what two intersect to give you that. That implies that minus Z alpha over 2. Anyone know what it is? Minus 1.65. So that implies that the critical value, if you just look at the positive Z alpha over 2, critical value is 1.65. What we'll look at next chapter is what happens when I just look at one tail. How does that change finding the critical value? And the idea is still the same. What was the next step? Find the standard error. And we just said a second ago, the standard error is found by this p hat times 1 minus p hat over n. So we have p hat here. So just plug it in. And you have the sample size here. 0.23 times 1 minus 0.23 is what? Yeah, 0.77. Then divided by 1400. If you do it on the calculator, be very careful, because sometimes if you do the square root and do this denominator, the numerator first, and then close the parentheses, and then do the 1400 after, it will take this square root here and divide it by that. I'll be wrong, and why? Because you're missing the square root on this part, so it's going to multiply it by a factor of the square root of 1400, greater than what it should be. Then this is your standard error, and I have no idea what that is as a decimal. Will someone tell me? .0112. Cool. So p hat. We'll just write it. One minus there, divide by, which was whatever he said, 0.0112. What was the fourth step? Find the margin of error. And how do you find that? The critical value times the corresponding standard error. In that case, you get the critical value from part 2 and the standard error from part 3. That gives you 1.65 times 0.23 times 0.77 divided by 1400. And that gives you, what is it? It should be 0.02, I think, roughly. Then what's the last step? You have the confidence interval. So all you do is take the point estimate plus or minus the margin of error. So that would be 0.23 plus or minus 0.02, which gives you a confidence interval of what? 0.21. So that's just taking 23, subtracting off the 0.02. And then 0.23 plus 0.02 is 0.25. How do you think you write the interpretation in this case? Can someone who got it right on the exam kind of make it? All you do is replace the mean with the proportion. And you look at, in this case, screw it, I'll just write it. We are 90% confident. So it starts off the same exact way as it did before. That, and instead of the true population mean, it's the true population proportion. True population proportion of students. Golly, that got real crooked real quick. Who pay for their education. with student loans is what? This thing remains the same. Yep, correct. Is between 0.21 and 0.25. The interpretation is still the same. It's just in this case, we replaced population mean with population proportion. And this number is going to change. It'll be between 0 and 1. Everyone okay with that? Now, the last thing we talk about in this chapter is finding the sample size to achieve a margin of error when we're dealing with a confidence interval for the population proportion. Gosh dang it, I wish I could write on another board. Just like we did in chapter, whatever it is, section 7 point, I think it was 1. We can also find a sample size to achieve some margin of error in this case. So you have your margin of error, E in this case, is found by the critical Z value times the square root of P hat 1 minus P hat over N. You want me to show you how to solve for N? It's not that hard. First, divide by Z alpha over 2 on both sides. You get E divided by Z alpha over 2 is equal to the square root of P hat times 1 minus P hat over N. Then what do you think you do next? Square both sides. You do that. You get E over Z alpha over 2 squared is equal to P hat times 1 minus P hat over N. Now, what's the easiest way to solve for N? Yeah, flip both sides. So if you do that, you get Z alpha over 2 divided by E squared is equal to N divided by P hat is 1 minus P hat. And now you can see why I flip both sides, because you can just multiply by P hat times 1 minus P hat on both sides. That'll give you that N is equal to Z alpha over 2 divided by E, that quantity squared, times P hat times 1 minus P hat. So some of you use this formula on your exam for the bonus question. That was the bonus question from last year's exam for someone else. So in our case, the formula for the bonus question was different. And I won't say how. I guess I can put this here too, since I noted it on my notes. So P hat is X over N, just like we said earlier. Z alpha over 2 is the critical value. And then E is the given margin of error. In this case, we're going to be dealing with percentages. So the margin of error would be given as a percentage or as a decimal. I want to be 3% confident, or I want to be within 3% of the actual true population proportion. So that's what it would look like. What happens if N is a decimal? This is just the same idea as last section. Yeah, if N is a decimal, round up. Now, I mentioned these next two things because your homework will have you do both cases. So it says there are two scenarios to consider when finding the minimum sample size needed for estimating the population proportion. The first one, it says, or it doesn't say as you fill it in. Okay, so I guess I'll write it down here. If an estimate of p hat is given, use it. So that just means if I tell you what the sample proportion is, use that one. If I don't tell you what it is, then what do you think you would use? You want something that's going to maximize n or minimize n while keeping the, where's it at? This error the smallest. Anyone have any ideas? So what you want is p hat times 1 minus p hat to be large. Has anyone taken calculus yet? Okay. If you want to find the maximum at some point of a curve, what do you do? So you take the first derivative and set it equal to 0 and solve for the value. So for those of you who haven't taken calculus yet, don't worry about this. So do that. P hat times 1 minus p hat. If you multiply it out, that's p hat minus p hat squared. Then if you take the derivatives with respect to p hat, this becomes 1 minus 2 p hat. Set this equal to 0 and solve for p hat. This implies that 1 equals 2 p hat and that p hat is 0.5. That means if we do not have an estimate of p hat, then we're going to use p hat is 0.5 because it will maximize n. Does anyone know how to verify that's a maximum? I just like to ask this question every semester because some people have taken calculus and some haven't. To verify it's a maximum, you take the second derivative of that and see if it's negative. If you do that, it becomes -2, and -2 is obviously negative. If p is what? Use 0.5 if p hat is not known, is unknown. Because it will maximize the sample size. Where'd it go? This. Oh, that's why it says right here. Why do we use this? When p hat is 0.5, then p hat times 1 minus p hat is at its maximum. Then looking at the next example, it says a researcher wishes to estimate with 95% confidence the proportion of people who have a doctorate degree in mathematics. A previous study showed that 8% of those interviewed had such a degree. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So the confidence level is 95%. What is the critical Z alpha over 2 value corresponding to 95% confidence? You will probably want to memorize it. What's up? Well, that's the alpha over 2, yes. But the Z value corresponding of area 0.025 to the left. Anyone remember what it is? Positive and negative 1.96. You want me to draw out why? I will in case. Okay, so to find the critical value, look at this. We're again dealing with z-scores. And we say the area in between the lower and the upper is equal to the confidence level as a percentage. So 0.95 is in the middle. So that implies that 0.05 is in these two tails added together. So you have 0.05 divided by 2 in this one and 0.05 divided by 2 in this one. As a decimal, that's 0.025. Then you look at the area to the left of this z-score. So the area to the left of this is alpha over 2. The probability of z being less than or equal to negative z alpha over 2. If you want to remember it this way, that will come in handy. The probability of z being less than or equal to the negative z alpha over 2 is equal to alpha over 2. That just means the area to the left of the negative critical value is alpha over 2. Another way you could remember it is this. The probability of z being greater than or equal to the positive z alpha over 2 is what? The area to the right of this critical value. The positive one is what? Again, alpha over 2. So you can remember it those two ways. I'm mentioning that now because it'll probably be handy to know in chapters 8 and 9. In this case, alpha is 0.05, so this is 0.025. If you look for a critical value with area to the left of that, you get that negative z alpha over 2 is minus 1.96. So that implies that just the positive one of it is positive 1.96. Just take the negative off. Then you have z alpha over 2. What else do you need? So the formula says you need n equals p hat 1 minus p hat times z alpha over 2 over e squared. We have this part. We need this part and that part. Are they given to you in the problem? Hint, yes, they are. A previous study shows that 8% of those interviewed had such degree. So p hat is what? This implies that p hat is 8%, which is 0.08. Which implies that 1 minus p hat is what? Yeah, 0.92. And what is the error we want to be within? Yeah, within 2% of the true proportion. So that means that E is 2% as a decimal, 0.02. Plug in all of these into here. And you have n equals 0.02 times 0.98. That's just 1 minus p hat times z alpha over 2, which is 1.96, divided by E, 0.02 squared. Someone plug that in your calculator and tell me what you get. Anyone figured it out? Yeah, 707. 706.8 exactly. Nope, not that. 706.8. So that implies that you round it up to n is 707. That is the minimum sample size needed. Everyone understand how I did that, just plugging in the numbers? Does everyone get where I found the numbers of the question? What's up? It really doesn't matter. You're just multiplying the two numbers together, so it really doesn't matter the order. Yeah, so in the original thing I just said, you had n is equal to, the formula I gave a second ago was this, right? Are you asking why I moved this to the front? Yeah. Oh, why did I do that? Thank you. That should be right. There we go. I wrote it down wrong. I did the E and then 1 minus E instead of P hat and 1 minus P hat. There you go. That should be right. Yeah. Sorry for the confusion. Is everyone okay up to there now? That I completely wrote it wrong. The next part, what if no previous study was done? Find the minimum sample size necessary to be accurate within 2%. In that case, do you know P hat or not? No. So then you use the second rule. So you use that P hat is a what? Yeah, so you use P hat is 0.5. And just plug that in here with the same Z alpha over 2 and the same E. And you'll get that N is equal to 0.5 times 1 minus 0.5 is 0.5 times, what is it, 1.96 divided by the error, 2% squared. And what do you get? I think you actually get a whole number on this one. Yep, you get something a lot larger. Notice that this sample size needed in this case is a lot larger than this sample size, wherever it is, that one. So indeed, whenever P hat is 0.5, it does maximize the sample size. Everyone okay with that? Great. Then there's a little thing on the back that says summary. I really don't want to draw it up on the board, so I will show it, make it a lot easier. There. Oops, wrong button again. Come on, connect the camera. Come on. Sorry, people, I haven't even been looking at the chat. Can you do it on a calculator? Are you talking about the confidence interval thing? Sorry. You can actually do it on the calculator. Yes, you can. Actually, everything we've been doing this chapter, you can do on the calculator. And in the next 2 chapters, you can. There's one thing you can't do in the calculator in chapter 9 because it uses the different degrees of freedom. But everything else you can. Will I show you how to do it in the calculator? Yes. Make it a little bit easier. Okay, now let's see if this stupid thing was working. Great. Here we are. This is the little summary thing. Julius, quit calling me. I'm teaching right now. Should I answer my phone in the middle of class? Nope, we're not gonna do that. I guarantee he wants me to go open a door for him. Okay, so now you need to ask yourself, which confidence interval formula do I use? So the first thing says, what are we estimating? If you're estimating the mean, then you ask yourself, do you know sigma? If you know sigma, then you use the critical z values and the population standard deviation. If you don't, you use the critical t values and the sample standard deviation. And then the approximate sample size needed is given here. And remember, the degrees of freedom is n-1. That will change when we get to chapter 10. So you'll have to remember that. Then if we're estimating the population proportion, there's just one formula you will use is that. There is another one where you will use a critical t value, but we will not go over that. And then the sample size is just what we showed earlier. So that's a little summary thing for it. Will there be a summary thing for chapters 8 and 9? The answer is yes. It is a lot more complicated than that. If you want to write it down for the exam, you're willing to, but it's quite big. I just noticed how to do what. Are there any questions over any of that chapter 7 stuff? Great. Do we want to look at a problem from the homework or should I move on? Okay, great. We'll do that. Okay, get off there, off there. We'll look at a confidence interval thing. People online will show you it too. I just gotta load it first. I hate this stupid microphone echo. Let's go preview. I have no idea what number it will be. We'll see in a second. Let's go here, 21. What's that? Nope, you don't want that one. Not that one either. What the heck is 1? There we go. Okay, now let me show this to people online too. Zoom meeting, share screen, yes. Okay, people online, can you see that now? Okay, now I'm going to switch the camera also to front facing because I'm going to do it on the board. So do these problems actually match what's on your homework or not? Because I have no idea. Sometimes you'll get the same numbers I do and sometimes you won't. Oh, and I'll mention this now because I remembered. In chapter 8, there is one question that if you hit guided solution, you will automatically get no credit for the problem because there's only one problem that will give you. And I don't know which number it is. I'll have to remember. But it happened when I taught it during the summer and it happened last semester. So be careful which ones you do. I can't remember what it is. Yeah, let's see what it says. A CBS News / New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime. Given the chance, estimate the true proportion of adults who would like to travel to outer space with 93% accuracy. Round your answer to at least 3 decimal places. That is a weird confidence level. Then, what is p hat in this case? The sample proportion of people who would go to outer space if they could, and what is it? Yeah, 329 divided by the total sample size of whatever it is, 763. And then I guess round this to 3 decimal places. Where is my calculator? There it is. .4312. I guess I'll go to 4. So that's p hat. What else do you need to know? You need to know z alpha over 2. And you also need to know, well, you already know n, it tells you. This Z alpha over 2 is going to be weird. The area in between these two is the confidence level of 93%. Why does it pick such a weird number? What's the area in the left tail? If we want 93% confidence, what is alpha? 0.07. So then this is 0.07 over 2. That means the area to the left of this negative Z alpha over 2 value is 0.03. Let me look at the table because I have no idea what that is. I also don't know if it's going to be exactly on the table or not. There's 0.0351. We're going to use that. Negative 1.81. So that implies that Z alpha over 2 is 1.81. Everyone okay with that? That is a weird one. I don't know why your homework gives you such a weird one. Then you know n. What is n? 763. So you want me to do the step-by-step thing? Because I kind of already done all the steps. 1 is this, the point estimate. 2, the critical value is that over there, 1.81. 3, the standard error. We haven't done that yet. That's just p hat. 1 minus p hat. That is ugly. 1 minus p hat over n under the square root. That's whatever this is. 0.4312 times 0.5688 divided by whatever that sample size was, 673. No idea what that is. We will find out. By 763. If you do that, it's 0.0179. Then what's the fourth part? The margin of error. So take the critical value times that. 1.81 times 0.0179, and that'll give you 0.0324. And then the last step is get the confidence interval. That would be this part, 0.4312, plus or minus this part, 0.0324. And if we do that, it gives us 0.0324, 0.3899, or 3988. To what the no, not that. Sorry, I messed up on the calculator. 0.4636. So if it says round to 3 decimal places, what does this give you? 0.400 to 0.464. Should I dare check if that is correct? Let's do it. What was it? 0. 0.400 to 0.464. Ta-da! I'm so smart. This thing, same idea. In this case, what would be the population proportion? This is in a random sample of 200 people, 148 said they watched educational television. What is p hat? It's the proportion of people who watched educated television. And in that case, it's 143 divided by 200. Yeah, 0.715. And what's the critical Z alpha over 2 value corresponding to 99% confidence? Does anyone remember? It's 2.58. And then it says what n is, so you can plug into the formula to find it. I'm not going to do it on that one because I think it's the other question that's on your homework about this. Everyone okay with that? And then the other question that's over this is about the sample size thing, which we already went over. Okay. So now we'll start with chapter 8. So now is where the class gets hard, if it hasn't been already. So just like in chapter 7, we had Z and T intervals. So what do you think we'll have in chapter 8 since we're doing a hypothesis test? Just put Z and T in front. Z and T test is what we'll do. That's simple. So in chapter 7, we discussed how to use confidence intervals to estimate parameters. So in this case, we looked at two-tailed tests, is what they were been called in this case. And these were based on sample data. In this chapter, we will discuss how to properly test and answer questions about those parameters. And these are called hypothesis tests. So section 8.1 is all about the steps in a hypothesis test. And what is a statistical hypothesis test? So know this definition. It may pop up somewhere. Hint, note. A decision-making process for evaluating claims about a population based on information obtained from a sample. Is that already in your notes? I can't remember if I typed it or not yet. Some of the stuff I typed because it had too much to fill in. In order to set up a hypothesis test, you must first define the question you wish to answer, and this is what we will call the hypothesis. And it says right here, a statistical hypothesis is a conjecture about a population parameter. So we're saying a population parameter is equal to some specified value, and we're going to figure out what is the probability that actually happens. And then associated with that probability, we can either reject or fail to reject this claim of interest. In this chapter, we'll just look at mu and p. So there is a hypothesis test for sigma and sigma squared. Does anyone want to do those? Because I don't. Yeah, that's stuff that will save if you take a 4,000 level statistics class. You will look at something called the chi-square distribution and the F distribution. They are both right skewed distributions, fun fact. So then we will look at two types of hypotheses. The first one is called the null hypothesis. And how is it defined? So one, the null hypothesis. We will denote this as H with a, what do we call that, subscript O? Yeah, I know, y'all are laughing. It's a ho. And this is a statistical hypothesis. Stating, how do I put it? There is no difference between a population parameter and a specified value. So what in the world does that mean? Then an example, I say, for example, let's say we want to estimate the population mean mu. Then the null hypothesis would look something like this. Mu is equal to 10. Or if you want to estimate the population proportion P, it would be something like P is 0.65. It's saying the parameter that we're interested in is equal to some specific value. And then the alternative will just be the opposite. So the alternative hypothesis we will call this, we call it H1 or HA? Okay, I put both, H1 or HA. HA, A means alternative, H1, it just goes 0, 1. So if this is a statistical hypothesis stating there is no difference between a population parameter and a specified value, how would you define the opposite of that? Yes, very good. So a statistical hypothesis stating there is a difference. Okay, can I put not HO? We all know what that means. Just put there is a difference there. And ta-da, that's what that is. I just don't want to write the whole thing down again. Then what could that look like? There will be 3 different things we'll look at. So in this case, the alternatives for mu equals 10. So there are 3 different ones. So we could say mu does not equal 10, mu is less than 10, or what's the final one? What's the opposite of less than? Mu is greater than 10. And then the same thing for this. P does not equal 0.65. P is greater than 0.65, or P is less than 0.65. So it doesn't matter which one of these as I choose as the alternative. So if there are 3 different ones, obviously it matters. Because this alternative here will determine what is the rejection region, and that will determine what the critical value is. And if you don't have the right critical value, it could give you the wrong decision. So it says, let's look at some examples. State the null and alternative hypothesis for each conjecture. A researcher thinks that if the expectant mothers uses vitamin pills, the birth weight of babies will increase. The average birth weight of the population is 8.6 pounds. In that case, I'll put this as A. What is the null hypothesis? States that there's no difference between a parameter and a specified value. In this case, what is the parameter we're interested in? Yeah, birth weight. And what is that? Is it a mean or a proportion? It's a mean. So that means that mu is going to be equal to some specified value. And what is the specified value in the problem? 8.6, correct. Now the alternative states that there is a difference. So in this case, it says if she takes vitamin pills, the birth weight will increase. So what does that mean the alternative is? Yeah, greater than. Mu is greater than 8.6. What if it said mu is less than 8.6, or the mean decreases? It'll be mu is less than 8.6. If it says, is there a difference between the mean, then it would be not equal to. Let's look at the next one. An engineer hypothesized that the mean number of defects can be decreased in a manufacturing process of USB drives by using robots instead of humans for certain tasks. The mean number of defective drives is 18. What does that imply about the null hypothesis? Are we looking at a mean or a proportion? A mean, so in that case it's mu, and it's equal to what? Yes. And what is the alternative? So it says if we use robots over humans, then the mean number of defective drives will decrease. So under the alternative hypothesis, mu is less than 18. Is there an easy way to determine the alternative? Yes. Will I give you the little thing? Yes. I didn't have a sheet until last semester. I saw it on someone else's notes and I took it. I'll have to find it. And the last one, I guess we'll do this and then we'll bounce. A psychologist feels that playing soft music during a test will change the results of the test. The psychologist is not sure whether the grades will be higher or lower. In the past, the mean of the scores was a 73. So what does that imply about the null hypothesis? Yeah, mu is 73. And what is the alternative? Yeah, it does not equal because she doesn't know if it'll be higher or lower. So in that case, we just say mu does not equal 73. All right, I guess we'll pick up there next time. If y'all have any questions over how I graded your exam, just come up here.